on, baby, yeah, we should be closer than friends.
In this video, we are investigating the reaction of baking soda and vinegar, as well as looking at the application of this reaction in cooking. We will calculate the theoretical yield by identifying the limiting reagent. We will determine the experimental yields and calculate the percentage yield. Let's get started with the theoretical yield. And here's the reaction. The reactants are baking soda, acetic acid, which are producing sodium acetate, water, and carbon dioxide. And here is the balanced equation. At the start of the reaction, we have 4.2 gram for baking soda and acetic acid. At this point, there's 0 gram of carbon dioxide or 0 milliliters of carbon dioxide produced. To get the initial moles, we need to use the molar mass, and for that, using the relative atomic mass. So for sodium 23, hydrogen 1, carbon 12, and 3 times 16 of the oxygen, which totals up to be in 84 grams per mole. We will do the exact same thing for acetic acid. Particles, could be atoms or molecules, are like a half a dozen of apple, just a number of apple, which means then that moles would be a bag of that apple, of this half dozen of apple. So that means mass would be us weighing that bag and getting the weight. How do we get from one to another? So with particles to moles, we got to divide by Avogadro's constant. Now Avogadro's constant is just telling us how many apples fit in a bag. So for moles to mass, we times it by the molar mass. The molar mass is the same number as the relative atomic mass or the relative formula mass. On the way back, we do the opposite. So for mass to moles, we divide by the molar mass. And then for moles to particles, we times by the Avogadro constant. So in our calculation, we're actually interested to go from mass to moles. And for that, we need to take the mass and divide it by the molar mass to get the moles. So for the baking soda, we do 4.2 grams divided by 84 grams per mole. We cancel away the grams to get to mole. In this case, it's 0.05 moles. We do the same thing for acetic acid, which means 0.07 mole for that. To calculate a limiting reagent, we now need to look at the ratio of baking soda and acetic acid, which is 1:1. Now the scenario of having baking soda being limited, we then would have 0 mole left at the end of the reaction. Now to get acetic acid, we need to divide the 0.05 mole by 1 and then times it by 1, which means 0.05 mole we should have used, but we have 0.07 mole available, so we actually have 0.02 mole left over. We already know with that soda is limited and that acetic acid is in excess. But just to run the scenario the other way around, if we now have the vinegar limited, it would be 0 mole, and we actually find out that it is impossible to have enough of the soda. Since baking soda is our limiting reagent, we're now comparing the moles of baking soda to carbon dioxide, and the ratio is 1:1. So by the end of the reaction, we should have 0 moles left of the baking soda and 0.05 moles produced from the carbon dioxide. You need to convert it to volume, and in that we're assuming that in the reaction there's a standard temperature and pressure. Under the assumption, we can now apply this calculation where moles equals volume divided by molar volume. Molar volume is a 22.7 decimeter cubed per mole for any gas. Now under this assumption, we can now calculate that, do a little bit of algebra. So volume would be moles times molar volume, in this case 0.05 moles times 22.7 decimeter cubes per mole, which will make a 1.135 decimeter cubed or 1,135 milliliters. To determine the experimental yield, we need to collect and record experimental data. So let's go! Looking at our reading, we have collected 52 milliliters of carbon dioxide. To calculate the percentage yield, we need to take the experimental yield that we have just collected and divide that by the theoretical yield that we have previously calculated. We times that by 100% to get the percentage yield. So let's do that at our example. So we're going to take 52 milliliters and we're going to divide that by the 135 milliliters that we have calculated, times that by the 100%, which will give us the 4.6%. It's a very low percentage, so we should think about what errors might have had occurred in the experiment. This cooking lab demonstrates an application to a real-world scenario.
Open up. Open up.
After we measured the height the cake has risen, we can plot that against the amount of baking soda and vinegar we have used, and excluding some anomalies, we can see that with more baking soda and vinegar that the cake will rise more, which is expected because there's more carbon dioxide produced. And with more carbon dioxide produced, the cake will rise higher.